Okay, so in this video, we're going to be looking at doing a 4x4 determinant, but we're going to do it both ways. We're going to do it by row reducing, and we're also going to do it by expansion. So let's start with doing it by expansion, because I think it'll make it really clear what the advantages of row reducing are if we do it by expansion first. So we don't have a lot of zeros in this matrix. So I'm just going to expand on the first row, sort of standard. I do have a 0, and so that will keep me from having 4 3x3 matrices. I'll end up with only 3 3x3 matrices. So expanding on the 1, and then I'm going to have a 3x3 matrix left behind. And since I'm expanding on this one right here, that will leave behind -6, 1, 2, 0, 4, -2, and -1, 0, 5. And then we go over to the next one. So the sign changes. And then we have another 3x3. And we're canceling out the first row and the second column. So I get 0, 1, 3, and second column out. So then 1, 4, 0, and then 2, -2, 5. Then I go over the next one. So I change sign again. And now I'm blocking out this column. So 0, 1, 3, and -6, 0, -1. This one's out, and I end up with 2, -2, 5. And then the next one I don't have to worry about because I'm multiplying by 0. Again, the sign changes. I'll just fill that in with whatever, because who cares? It's multiplied by 0. So we just really have these 3 matrices that we have to worry about. Now, obviously the ones here, we don't have to worry about them. Now let's see what we can do to reduce this a little further. We have some zeros we could use to simplify things a little bit. So in this first matrix, I have the 1, I can throw it away. I'm going to expand on this first column. So that's going to give me -6 times my 2x2, get rid of this one and this one. That's going to give me 4, -2, 0, 5. And then this was a positive entry position-wise. This is my negative entry. It's 0. So again, I'm not going to write it anymore. It's 0 because I'm multiplying whatever the result is by 0. And then this is back to a positive entry. And I'll just, again, indicate that with the plus the -1. And then my 2x2 determinant, cancel out this column and this row. I end up with 1, 2, 4, -2. So this piece up here. All right, so that's from this one. Now in the next matrix, I have a minus. And so I'm going to put everything in square brackets. And if I expand, let's say on this first row or the first column, doesn't really matter. Let's just do the first row. This will be my positive position, and therefore it's multiplied by 0, and it doesn't matter. So I move over here. This is my negative position. and then I get a determinant, canceling out this row and this column in the middle, because that's where my 1 is. So I get 1, 3, and -2, 5. And then I go over to my 2, we're back to a positive position. And canceling out this row and this column, I get 1, 3, and 4, 0. And then my 2, again, if I expand on first row, first column, whatever, we'll just do the first row. The first matrix is 0, then I'm in a negative position. And then my determinant, my 2 by 2 determinant, will be canceling out this row and this column, 1, 3, and -2, 5. And then again, going over here, this is now a positive position again. And canceling out this row and this column, I get 1, 3, and 0, -1. All right, so now we're down to 2 by 2s, and so now we can start doing some calculations. So -6 gets multiplied by 4 by 5 is 20, minus 0, because 0 times -2 is 0. And then -1 times, let's see, 1 and -2 is -2, minus 4 by 2, which is 8. And then we'll deal with that distributing the minus sign later. Minus 1 by 5 is 5, and then minus a -6, plus 2 times 0, 1 times 0 was 0, minus 12, and then close the bracket, and then 2 times, so 6 minus minus becomes a positive, and then 1 by 5 is 5, minus a -6, plus 2 times -1 minus 0. So 20 minus 0 is 20, times -6 is -120. But then -2 and adding -8 gives me -10, but then times the -1 gives me +10. 5 minus a -6, that's 5 plus 6, that's 11, that's -11. And then -12 times 2 is -24. And then 2 times, so 5 minus a -6 is 11. 5 plus 6 times 6, 66, plus 2 times -1 is just going to give me -2. So -110. Minus 11 minus 24 is going to give me -35, but then I'm minusing it again, so +35. And 66 minus 2 is 64, times 2 is 128. And let's see if we get 53. It's a lot of little determinants. Let's try doing this from the row reducing perspective and see if that is any easier and if we get the same answer. So from the row reducing perspective, I'm going to probably, again, tackle it by this first column. And so I'm going to use minus row 1 plus row 3. Put that back in row 3. That does not change anything because I did not multiply row 3 by anything. And then minus 3 row 1 plus row 4 goes back to row 4. And again, the idea here is that I haven't modified row 4, multiplied row 4 by anything, so that does not change the determinant. It would only change the determinant in this case if I put it back into row 1. So -1 plus 1 gives me 0. -1 plus 0 is -1. -2 is -2 plus 4 is going to give me 2. And then 0 doesn't change anything. -3 times 1 is -3 plus 3 is 0. -3 times 1 is -3. This gives me a -4. -3 times 2 is -6. And then 0, that doesn't change anything. All right, so then again, we can expand just to make our lives a little easier. We can expand on this first column and get a 3 by 3. I mean, technically this is times 1, but -6, -1, -4, 1, 2, -6, 2, -2, and 5. Okay, great. So again, we could try to, again, expand on one of these, but I'm going to swap some rows and flip a sign just to make my calculations a little bit easier. So I'm going to take row 1 and row 2, and I'm going to switch their places, and that multiplies my determinant by a -1. But then I'm going to take my new row 1 and I'm going to multiply by -1, and multiplying any row by a number is also going to multiply the determinant. And so the two negative signs will cancel out. And so my matrix is going to become, so first switch them. So -1, -6, 2 and 1, -2 and +2. So again, I just switched everything, and then I put a negative through row 1. And now I'm going to do some more row operations. So 6 row 1 plus row 2. And as long as I put it back in row 2, I have not changed my determinant. And then same thing for 4 row 1 plus row 3. I'm going to put it back into row 3. And so I have not changed my determinant. And so 6 times 1 is 6 plus -6 is 0. 6 times -2 is -12 plus 1 is going to be -11. And then 6 times positive 2 is 12, plus 2 is 14. 4 times 1 is 4, plus negative 4 is 0. 4 times negative 2 is negative 8. It's going to give me negative 14. And then this is positive 8. 4 times 2 is positive 8. That's going to give me 5, and 8 is 13. And then again, I'm going to expand this. On the first column, and that's going to leave me with a 2 by 2, negative 11, 14, negative 14, and 13. And if I really want to, I can just calculate the determinant from here. Negative 11 times 13 minus negative 14 times 14. And assuming I haven't made any arithmetic mistakes, negative 11 times 13 plus 14 times 14 gives me 53. And so again, both processes are going to give me the exact same answer. When you're dealing with certain kinds of matrices, again, if you've got a lot of zeros, expanding is not a bad way to go. If you don't have a lot of zeros, row reducing can be simpler. And as you can see, you can reduce it to, you're still reducing it in some sense, but you're reducing it to one submatrix instead of, as we saw earlier, we ended up with 1, 2, 3, 4, 5, 6 2 by 2s instead of one 2 by 2. So again, both of them work. And typically in a linear algebra course, you are required to be able to do both of these processes. So once you leave linear algebra, or if it doesn't specify, then you can use whichever one you prefer in that particular instance. But typically you do have to know how to do both of these determinant methods.